Hello. Today we will want to solve the following nonlinear system of equations. Our first equation is given by x squared plus y squared is equal to 16. You should recognize this as the equation of a circle centered at the point 0, 0 with radius 4. Our second equation is given by x minus 7 squared divided by 9 plus y squared divided by 25 equals 1. And if you don't recognize this, we'll talk a little bit more about it in chapter 10, but this is the equation of an ellipse centered at the point 7, 0. Solving the nonlinear system, again, means that we want to find all pairs x and y that satisfy both of these equations. And we have a couple methods in our tool belt to do so, but it turns out that since we have this y squared by itself and this y squared by itself, that substitution will probably be the easiest method. Since this y squared is not next to anything else, I can actually solve for it here in the following manner. I move this x squared to the other side, leaving me with the equation y squared is equal to 16 minus x squared. And now I can take this y squared and plug it in here into our second equation, leaving us with the following. This first term does not change. X minus 7 squared divided by 9 plus, now that we know what y squared is, 16 minus x squared divided by 25 is equal to 1. And even though it's not written in the form we normally see it as, this is a quadratic equation in x, which means that we can rearrange in a way where we're allowed to use the quadratic formula. To do so, we typically use the form ax squared plus bx plus c equals to 0. So we need to do a bit of rearranging before we can use the quadratic formula here. To do so, I'll need to square this binomial, clear out the denominators, combine all of our like terms, and move whatever ends up over here to this side so that we're equal to 0. And that seems like quite a few steps, so I'm going to do it over on this side here and save these middle panels for our actual solution. So let's title this our scratch section here. Let's do the first step of canceling out these two denominators. And we do so by multiplying through by the least common multiple, which in this case is 225, which is exactly 9 times 25. So I have 9 times 25 times x minus 7 squared over 9 plus 16 minus x squared over 25 times 25 times 9. All of this is equal to 1 times 25 times 9. And I'll trust that you can do some simplifications. We see that these 9s will divide to 1, these 25s will divide to 1. This becomes 25x minus 7 squared plus 9 16 minus x squared is equal to 225. Now we should be able to square this binomial and distribute through. This gets us 25x squared minus 14x plus 49. Now push this through as well. 9 times 16 is 144. 9 times negative x squared is negative 9x squared. All of this is equal to 225. Keep going. I can now distribute this 25x squared in and start combining some of my like terms here. I get 25x squared. 25 times negative 14 is, let's see if we can do this. 10 times 20 is 200. Let me check my cheat sheet here. This should be equal to negative 350 multiplied by x, and 25 times 49 is equal to 1225. plus 144 minus 9x squared equals 225. And this is getting much closer to the form we're used to seeing it. If I combine these like terms, I get 16x squared. There's no x term other than this negative 350x. And then 1225 plus 144 minus 225 is 1144. And at this point, it's now equal to 0. So, just a quick reminder on what the solutions are. They're given by the quadratic formula. We know that x is equal to 350 plus or minus the square root of 350 squared minus 4 times a, which is 16, times c. Now I almost forgot, we need to divide by 2a. Now in the spirit of saving time, you can just plug this into your calculator, and the two solutions you get, because we get one for plus and one for minus, when it is minus we get 4, and when it is plus we get 17.875. So we would like to take these, plug them both in, and see what values for y they get us. But we're actually going to run into a problem. When x is equal to 4, we do in fact live on the circle, and we won't run into any issues. But this x equals 17.875 is far too big to be on this circle, because again, this is centered at 0, 0 with radius 4. And so it turns out that this 17.875 is an extraneous solution. Again, if we tried to solve for y here, we would have to square 17.875, which would be way bigger than 16, and would only give us complex roots for y. But again, we're looking for pairs x, y in the real plane, meaning that this is an extraneous solution. So, by the scratch work, x has to be 4. Since we already solved for x, we can use either equation to solve for y. And it seems like the first one's going to be a little bit easier. So let's plug this into equation 1. And this gets us 4 squared plus y squared is equal to 16, which simplifies to 16 plus y squared equals 16, telling us that y squared is 0, meaning that the solution is given, the solution has to be y equals 0. So as an ordered pair, our final answer is the point 4, 0. Meaning this circle and this ellipse touch only at one point. And if you're curious on why, let's do a quick sketch, maybe not super accurate, to see where this point lives. On the xy plane here, we know that this circle is centered at 0, 0 and has radius 4. So if we make a crude sketch here, this comes from this top equation. And again, we'll talk more about how to graph these in section 10. But we know that the center of this ellipse is at the point 7, 0. And we know, we'll talk about this later, that this has a minor axis of radius 3 and a major axis of radius 5, meaning it's tall and skinny. It'll look somewhat like this. And here, this ordered pair is exactly the point here at the bottom where the two the circle and the ellipse just barely touch.